Welcome to Knowledge Gainer 1 channel. 15th question in LCM and HCF topic is: an inspector of school wishes to distribute 84 balls and 180 bats equally among a certain number of people. Find the maximum number of children who can receive them. Here, to find the maximum number of children, we should find the HCF of 84 and 180. So, HCF of 84 and 180. 84, 180. 2 times is 168. 12 is the remainder. 84, 7s are 84. So the maximum number of children who can receive them is 12. The HCF of 84 and 180 is 12. 60th question is: 21 mango, 42 apple and 56 orange trees have to be planted in rows such that each row has the same number of plants of one variety. Find the minimum number of rows in which all the trees can be planted. Now we should find the HCF of 21, 42 and 56. What are the factors? 7 and 3. 2 into 7 and 3, 7 into 2 power 3. So HCF is 7. Minimum rows, the formula is total trees by HCF of these three numbers. So 21 plus 42 plus 21 plus 42 plus 56 by 7, which is equal to 17. The minimum number of rows is 17. 17th question: find the least number exactly divisible by 8, 12, 15 and 21. Here least number is asked. So we should find the LCM of these numbers. Now let us write the factors of these numbers individually. After writing the factors, LCM is all the bases with highest power. 2 power 3 into 3 into 5 into 7. Now the LCM is 840. So the least number exactly divisible by all these four numbers is 840. 18th question: find the least number when divided by 25, 40, 60 leaves a remainder of 7 in each case. We can find this. The required number is equal to LCM of these numbers plus remainder. LCM of 25, 40, 60. The prime factors are 5 square, 2 power 3 into 5, and for 60 it is 2 square into 3 into 5. LCM of these three numbers is 600. The required number is LCM plus remainder. 600 plus 7. So the number is 607. Find the least number when divided by 24, 32, 36 leaves a remainder of 19, 27 and 31 respectively. We can get this from the required number is equal to LCM minus the common difference. The given numbers we should write. Remainders also we wrote. The difference is here 5. Here also it is 5. Here also it is 5. The common difference is 5. So the required number is equal to LCM of these three numbers is 288 minus common difference is 5, which is equal to 283 is the required number. Find the least number of 5 digits exactly divisible by 8, 12 and 15. Here the required number is, the least 5 digit number is 10,000. So 10,000 plus LCM minus remainder. We should find the LCM of 8, 12 and 15. Here the LCM of 8, 12 and 15 is 120. Now we should find the remainder. 120 divided by 10,000. 8 3 times is 960. 400. 3 times is 360. 40 is the remainder. Required number is 10,000 plus LCM is 120 minus 40, which is equal to 8. The required number is 10,080. Question number 21. Find the least number of square tiles to cover a rectangular room of length 1517 and breadth 902 is. Here the formula we use is number of square tiles is equal to area of the room length into breadth by a square. Here a is the HCF of length and breadth. Now HCF of length and breadth is HCF of 1517 and 902 is 41. Now to find the number of square tiles, let it be n. N is equal to 1517 into 902 by 41 into 41. That is length into breadth by a square, which is equal to, on calculating we get 814 square tiles are required to cover the rectangular room of the given length and breadth. Question number 22. What is the greatest number that will exactly divide 1600 and 1420? Here the greatest number is asked. We should find the HCF of 1600 and 1420. Now let us find the HCF. 1420. 1 times is 1420. The balance is 180. Take 1420. 7 times is 1260. The balance is 160. Take 180. 1 times is 160. The remainder is 20. Now take 160. 8 times is 160. So the HCF of 1614 20 is 20 is the HCF. The greatest number that will exactly divide 1614 20 is 20. Question number 23. What is the greatest number that will divide 38, 45 and 52 and leaves a remainder of 2, 3 and 4 respectively? We should subtract the remainders given and we should find the HCF of these 36, 42 and 48. Now let us write the prime factors of these numbers. After writing the prime factors, now let us find the HCF of 36, 42 and 48. HCF is the common base with least power. The common bases are 2 and 3. The least power is 2 power 1 and the least power of 3 is 1. So the HCF of 36, 42 and 48 is 6, which is the greatest number that will divide all these three numbers. Find the greatest number which will divide 410, 751, 1030. So leaves a remainder of 7 in each case. Here the greatest number is asked. We should find the HCF of 410 minus 7, 751 minus 7, 1030 minus 7. Now the HCF of 403, 744 and 1023 is 31. So the greatest number which will divide these three numbers leaving a remainder of 7 in each case is 31. Question number 25. Find the greatest number which divides 76, 151, 226 and leaves the same remainder in each case. In the above question, the same remainder 7 is given. Here a particular number is not given. Now let us take x is equal to 76, y is equal to 151 and z is equal to 226. Now x minus y minus z, z minus x. We should find it out. So the numbers we get are 75, 75 and 150. We should find the HCF of these three numbers. Now the prime factors of 75 are 5 square into 3. Here also 5 square into 3. And for 150 it is 5 square into 3 into 2. To find the HCF, we should take the common base with least power. So common base is 5 and 3. Least power is 5 power 2 and 3 power 1. 25 into 3 is 75 is the HCF for these three numbers, which is the greatest number which divides these three numbers with leaving the same remainder. Question number 26. Find the 4-digit smallest number when divided by 12, 18, 21 and 28 leaves a remainder of 3 in each case. Required number is equal to the smallest 4-digit number is 1000 plus LCM minus remainder. We should find the LCM of 12, 18, 21 and 28. The prime factors are 3 into 2 square, 3 square into 2, 7 into 3 and 7 into 2 square. To find the LCM, we should take all the bases with the highest power. So 2 into 3 into 7. Highest power of 2 is 2. Highest power of 3 is also 2 and highest power of 7 is 1. The LCM of these three numbers is 252. Now we should find the remainder. 252, 1000 divided by 252. 3 times is 756. The remainder we get as 244. So the required number is equal to 1000 plus LCM is 252 minus 240 plus 3, which is equal to, we get 1011 is the required number. Question number 27. Find the greatest 4-digit number when divided by 12, 15, 20 leaves no remainder. To get the required number, we must subtract the remainder from the greatest 4-digit number. The greatest 4-digit number is 4 nines. That is 9999 minus remainder. To get the remainder, we should divide the greatest 4-digit number with the LCM of these 4 numbers. LCM of 12, 15, 20 and 35 is 420. 9999 divided by 420. For 23 times, we get 9660. The remainder is 339. To get the required number, 9999 minus 339. 9660 is the required number. Find the greatest 4-digit number which when divided by 12, 18, 21, 28 leaves a remainder of 3 in each case. Required number is greatest 4-digit number minus remainder plus the k value, that is the remainder given in the question. To find the remainder, first we should find the LCM of these 4 numbers. The LCM of these numbers is 252. Now we should divide the greatest 4-digit number with 252. 9999 divided by 252 is 39 times 9828. The remainder is 171. Now the required number is equal to, the greatest 4-digit number is 9999 minus the remainder we got is 171 plus the remainder given in the question, that is 3, which is equal to 9931 is the required number. Question number 29. Find the least number which when divided by 5, 6, 8, 9, 12 leaves the remainder 1 in each case, but when divided by 13 leaves no remainder. To solve this problem, first we should find the LCM of these values. LCM of 5, 6, 8, 9, and 12 is 360. The required number will be in the form of LCM into some constant k plus 1. K is an integer. When the given number is divided by 13, it leaves no remainder. So divide the number, that is 360 27 times. If we divide 360 with 13, we get a remainder of 9. Now 360 into k plus 1 is equal to 13 into 27 plus 9 into k plus 1. The value of 360 is 13 into 27 plus 9 into k. So we can write this as 13 into 27k plus 9k plus 1. K may be any value, but this term is divisible by 13. Now we should make 9k plus 1 divisible by 13 by substituting the values as 1, 2, 3 and so on in 9k plus 1. 9k plus 1 is divisible by 13 when k value is 10. On substituting k is equal to 1, k is equal to 2, k is equal to 3 and so on. When k is equal to 10, 9k plus 1 value is divisible by 13. The required number is 360 into k plus 1. That is 360 into 10 plus 1. We get 3601 is the number. Question number 30. There are n numbers. HCF of each pair is x. LCM of n numbers is y. Then the product of n numbers is x power n minus 1 into y. Let us see an example. There are 4 numbers. HCF of each pair is 3. LCM of 4 numbers is 116. What is the product of the 4 numbers? We get the product of the numbers by using the above formula. X is the HCF, that is 3 power n is 4 here. 4 minus 1, LCM is 116. 3 power 3 into 116. We get 3132. Question number 31. The sum of two numbers is 1250 and their HCF is 81. How many pairs of such numbers can be formed? As HCF is 81, let the two numbers be 81A and 81B. But sum of the two numbers, that is 81A plus 81B is equal to 1215 is given. So A plus B value is 1215 by 81, which is equal to 15. Now to get the value 15, A and B must be either 114, 2 or 13, 12 and 3, 11 and 4, 10 and 5, 9 and 6, 8 and 7. Only these pairs, on adding these values, we get the sum as 15. Among these 7 pairs, only 4 pairs, that is 114, 2, 13, 11, 4, 8 and 7 are co-primes. So there are 4 pairs whose sum is 1215 and their HCF is 81. To find the values, we can substitute 81 into 1, 81 into 14, 81 into 2, 81 into 13. Same way these two values also. Question number 33. The sum and difference of LCM and HCF of two numbers is 592 and 518 respectively. Sum of two numbers is 296. Find the numbers. Let the LCM be L and HCF be H. The given sum is 592 and the difference is 518. So LCM plus HCF is 592. LCM minus HCF is 518. So on cancellation of 2 H's, 2L is equal to 592 plus 518. L is equal to 555. From this we can get H is equal to 37. We got HCF as 37. Let the first number be 37A, second number be 37B. The sum of the two numbers is 296 is given. Now taking 37 as common, A plus B is 296 into A plus B. A plus B is equal to, on cancellation, 8 times A plus B is 8. A and B must be co-primes. Here the possible pairs whose sum is 8 is 1 and 7, 3 and 5. To get the numbers, 37 into 1, 37 into 7, 37 into 3, 37 into 5. The pair of the numbers are 37, 259, 111 and 185. Now find out the pair which satisfies the given information in the question. We learnt a note point that the product of the HCM and LCF of the numbers is equal to product of numbers. Now let us find the product of HCF and LCM. HCF into LCM is 555 into 37, which is equal to 20535. This is LCM and this is HCF. Now by multiplying which two numbers, we get the same value. Let us see, 111 into 185. We get 20535. So this is the correct pair. Please like, share and subscribe to Knowledge Gainer 1M channel and share with your friends.